All right, welcome back again. So we have to look at another type of unsupervised learning algorithm called density-based clustering. Now, when I say density-based, there are different types of density-based. So we are going to look at them briefly, and then we are going to focus on particular one for now. And when I say density-based clustering, is actually based on the idea that clusters are regions of high density separated by regions of low density, right? So the algorithm works by first identifying core data points, which are data points that have a minimum number of neighbors within a specified distance. This core data point form the center of a cluster. Next, the algorithm identifies border data points, which are the data points that are not core data points but have at least one core data point as a neighbor. And finally, the algorithm identifies noise data points, which are data points that are not core data points or border data points. So these are just the concept of a density-based clustering. Now, there are three popular types of density-based clustering algorithms. One of them is called DBSCAN, density-based spatial clustering. This groups data points that are close to each other, which is called dense regions, and marks outliers as noise. So it has two parameters, EPS and minimum samples. Maximum distance between points to be considered as neighbors, these are called EPS, and the minimum number of points to form a dense region, which calls that's minimum sample. So the second type is optics, ordering points to identify cluster structure. This creates a reachability plot to show an density-based clusters at different distances. Features are does not require a fixed EPS, unlike DBSCAN, and it builds a hierarchy of clusters using a reachable graphs. All right. Now, the third one is called DBSCAN, called hierarchical DBSCAN. It improves DBSCAN by automatically finding clusters of varying densities using a hierarchy. So this one no need to specify EPS cluster. It automatically adapts to density changes. It's better at handling clusters of different shape and sizes. Okay, so but we are going to focus majorly on this today because of its significance, and because it's very simple and easy to run. So you can see the code is very short as well. It does not take too long. So when and which one to use? Number one is DBSCAN. Let's look at the best for simple density-based clustering, with clear EPS and mean samples. Okay, very easy. And the optics are used when you need a flexible hierarchical view of clusters. And the DBSCAN idea for dataset with a varying densities or unknown cluster shapes. All right, so let's how this currently works. Number one, it randomly selects a data point that has not been visited. If the data point has at least minimum points, neighbors within this distance EPS, it creates a new cluster and add the data point and its neighbors to the cluster. If the data point does not have at least minimum point neighbors within the distance EPS, mark the data point as noise and continue to the next data point. It repeats the step 1 to 3 until all data points have been visited one by one. So that is how it works. So let us see how we can implement this. So we are going to use the make moon function data set from the Scikit-learn library. So to create two moons, so make moon. So we're going to draw it. So we're going to import the library and load the data set first. So we load data set make moons, and this import make moons, and we use it to generate the data set. Then we perform DBSCAN clustering, by calling the DBSCAN library function here. We create our clustering is called the DBSCAN. We pass our two parameters, which we mentioned now, EPS and then minimum scan is 0.2 and 5. That's exchangeable. Then we fix our clustering here. All right, so when we run it, we have this. Then we visualize the result, and we import from a compiler. We import our Matplotlib. Also, we plot the first two columns here. You can see we use rainbow as our CMap. So you can see our listing here. You can see it. So this is what we have as our data. So this shape we generated now from the 2 months based on data set we used. And the advantages of DBSCAN is actually it arbitrary shapes handles non-spherical clusters better than k-means. So you can see the shape it handles, which is different from k-means type. Then no cluster count doesn't require pre-specifying the number of clusters. Outlier detection identify noise points naturally, and the parameter robustness less sensitive to initial parameter choice than k-means. Scalability efficient for large dataset, compute only local distances. So the merit is that the parameter sensitivity performance heavily depends on EPS and minimum samples. So on uniform density assumption struggles with clusters of varying densities, and non-deterministic result may vary across runs, and cost of dimensionality slower for high dimensional data. Noise limitation fails if noise density is too high. So that's not part of the training. All right, so that is that for today. We will be stopping there for now. So we'll continue from there in the next class by looking at another algorithms on unsupervised learning. Thanks so much for listening. I will see you in the next class. Bye for now.